All right, so let's talk about Swing. This is Swing is a Java library that allows us to create user interfaces, graphical user interfaces. It's not the most popular library out there. There's tons of other competing libraries for graphical user interfaces, but we've been in Java world for for the last couple of month or so. So let's stick to Java. Right. So up to this point, most of our focus has been implementing models as one of the overarching principles of isolation of concerns. Right. So the main principle that we've been trying to drive here is the isolation of concerns. Right. That if I'm going to do something, it should be only that, and I should do the best to my abilities to only do that one thing. Right. And models is certainly applying that principle. Right. Meaning, my concern is how I'm going to store the data, retrieve the data, update the data, and that's all I do. Right. I don't know how this is going to be rendered. Right. What colors you're going to use. What styles. Who's going to actually look at this? That's not my concern. Right. Whether it's bars or a pie chart or it's a line or whatever, that's not my concern. My concern is that I have the data. It's raw data. Right. I also am concerned with how that data is related to other data. Right. That I'm also concerned with the speed in which I can retrieve that data for you. Right. Any which way that I can transform that data, store that data for permanent storage, that there's no inconsistency, that there's no redundancy. So those are my concerns. Right. So the model is certainly one particular example of applying the principle of separation of concerns. Right. We've implemented the model. So that was one of them, one of the principles. The other one is the controller is also another principle. Is that at some point the model needs to change over time, right? As users generate more data, or data needs to be removed, or data needs to be updated somehow, that needs to be retrieved. So there are some affordances on this model, right? So we have to act on this model. So who should act on this model? And after decades of folks implementing all sorts of applications, they've come to the conclusion that perhaps it's not a good idea to mix and match. Whoever is rendering this data should not directly impact the data. They should not immediately have access to that data, right? As I mentioned earlier, the way you draw the data is not necessarily how you store the data, how you represent the data. Yes, you might have 3 integers, but decide that you want to render it as a pie chart or as a bar graph or whatever, right? And oftentimes it's a best practice to decide, wait a minute, the way I represent it has its own concerns, and the way I store it has a completely different concerns, right? And after many decades of implementing these kinds of applications, we've come to the conclusion that how you represent it should not have direct access on who and how you store it, right? That instead there should be some logical in between, right? That we've come to call the controller, right? The controller responsibility is to do the mapping between these two worlds, right? That I search a query in Google and it comes back with a billion results. It says, well, there's no way I'm going to display a billion results to a human user. I'll just show the first 10, right? And the controller decides, well, here are the first 10, and the user sees 10 and says, ooh, well, no, let me go to the next page. Yes, and the fact that we have pages or that we can paginate, again, that's a very user-centric concern, right? That we cannot possibly consume so much data. We need to go slowly, maybe 10 results at a time, right? That's a very human-centered concern, right? The data doesn't care that the user cannot consume a billion results. Right? Here you asked me for these results. Here they are, all billion of them. So separating that concern that the user needs to consume it, 10 at a time, that they can set how many elements per page, that they can sort it. All these are human centric issues, right? And the user can send these concerns, these events, these these limitations, these human limitations, through a controller and say, oh, give me the next page. Go to the previous page. Jump to page number 3, right? So all these are events that the user generates because of human needs. Okay. So the mapping between the way the humans interact, or how they want to consume the data, how they want to manipulate the data, and the transfer of how that actually is converted into real manipulation of the actual data, the controller is the one who's going to deal with those concerns. Yes. Also, as users generate a stream of events, I click, I type, I move the mouse, I touch, I'm interacting with this user interface. All that needs to be serialized, right? It needs to be, okay, these things are happening in this particular order, right? And they cannot conflict, and they can't contradict each other, right? So all these concerns of consuming this stream of events and serializing and synchronizing it and updating the model, those are tons of really big concerns. So all those concerns are dealt with in the controller, right? And there's also, and we talked about synchronous controllers, asynchronous controllers. We'll talk about that a little more as we go. And one of the things that we've discovered is that who should be responsible for updating the model or accessing the model or manipulating the model? The controller. The controller is the one who's going to convert our low bandwidth user communication into this high bandwidth communication with the model. Yes?
It feels like there's really tight coupling between the controller and the view. Like the controller still has to know that a page is the thing.
Right, exactly. The controller is the one that does the glue between the view, right, and the model. The model doesn't know about the view doesn't know about the model. It is the controller who knows about both of them, right, and does the conversion between the low bandwidth user interaction, right, into this object-oriented formal representation of the data model.
A little bit of coupling there is fine on either end.
Yeah, we use the controller to create the decoupling, right? And also we'll see today that there might be also some opportunities to decouple the controller with the model as well, right? To make that more generic. We'll first start with a version that is very, very tightly coupled, right? That it only works with that model, but perhaps there might be multiple representations of that model, and we'll use interfaces to do that. Yep. Yes, we're always looking for that other principle. That's a very good point, right? We're always looking for that the next principle of decoupling all these parts so that they can work with generic versions of each other. So today we're going to introduce finally the V in the MVC. Up to this point, our view has been spitting out or printing out something to the console, right? If it was the turtle, we ask the turtle, where are you and what have you done? It'll spit out maybe I'm at position XYZ, and it was two-dimensional, XY. Or these are the lines that I've drawn, right? And it spits it out to the console. So today we'll go a little further and actually have something to graph, something to draw. We'll start off with some really simple user interfaces, maybe an input field, a button, right, and maybe a label that we can change. So again, something really, really trivial, a trivial model, a trivial controller, a trivial. But even then, even in these trivial examples that we'll show today, there are opportunities to design it well or design it erroneously, right? So we'll look at and we'll make it simple, very, very simple, deliberately, so that we can focus more on the principles, right? So its only concern is to render this, right? Whether you're going to render this in a phone, or you're going to render it on a tablet, or on a desktop, or you're going to render it on a web page, right? The view is all three or all four different types of views would receive the identical model or the identical piece of data, right? But some of them might render using HTML. Some of them might render with React Native on a phone, or render it on a desktop using a Swing, Java Swing. Yes, but in all three cases, they're using the same identical model, right? Which is pretty cool. The model doesn't really care how you consume this, how you render this. So it's the view's responsibility to receive some data, not necessarily the model, right? Usually it's a subset, a very tiny sliver of what the model has. Yes, out of the billions of results, you're only getting 10, and you're only rendering those 10, right? And so the view's responsibility is to render, do the best best it can to render whatever it is passed along. Okay. Yeah. So first, we'll start with a poorly designed system, right? And it'll be even with a trivial. Even with a trivial example, you can get in trouble by doing it the wrong way. We'll talk about what's wrong with it. We'll see a couple opportunities on how to improve it. The first one will deliberately couple the view with the model. We'll have the view directly manipulate the model, right? And we should immediately have some flags go up and say, what? We're breaking some of the principles here. We'll then the next version we'll introduce the model to decouple both the view and the model, and we'll only have the controller have access to both, right, and be mapping user inputs to update the model. And finally, we'll try to generalize the control even further. We'll apply the command patterns that we introduced a couple days ago, right? And how would you implement it using specifically for the swing? How would you implement it in the swing infrastructure?